All right, so back from the break, and here's our homework for this week. I'm going to go ahead and zoom in on our first problem. It says, which formula could be used to determine the volume of a coffee can 8 inches high with a diameter of 4 inches? So I'm going to move this over, and I'm going to just try and draw a picture of what this problem is talking about. So we're having a coffee can, so we're going to have a cylinder. Do my best to draw a 3D object. So we have 8 inches high, and we have a diameter that is 4 inches is our diameter. So when we need to find the volume, our formula for a cylinder is volume equals capital BH. So remember that capital B equals the area of the base. And since our base right here is a circle, we can know that the area of a circle is pi r squared. So when we substitute this formula right here, when we substitute this in to our formula right here, we have volume equals pi r squared times our height. So our other problem is that we have diameter, but we need radius. So diameter is the whole length, whereas radius is only, this is our radius. So in order to find that, we have to divide our diameter by 2. So our radius is going to equal 2 inches. So we have a radius of 2, we have a height of 8. And so when we plug those into our formula right here, we're going to have volume equals pi times 2 squared times our height. All right. Consider the following numbers. Pi square root of 49.287, square root of 9 over 16, and negative square root of 25. Okay, so it says how many of these numbers are rational? Rational numbers. So rational numbers are numbers that can be written as fractions. They have decimals that are patterned or repeating. So hopefully you can go through that list and remember that not all square roots are rational or irrational, but they can be determined based on what their decimals look like. For this triangle, which statement demonstrates the Pythagorean property? So the Pythagorean states that a squared plus b squared equals c squared. So a and b are our legs, and c is our hypotenuse, which has to be our longest side. So remember that our right angle always points to our right angle always points to our hypotenuse. So they've just changed the letters around for this one. All right, what scale factor of dilation that maps A, B, C to A prime, B prime, C prime? So A prime, B prime, C prime, this one right here is our pre-image, and this one is our image. So we start, this is first, this is our changed. So we're starting right here. I'm going to go ahead and we have this one here is our image, and this is our pre-image, and the green is our image. So is it getting smaller or bigger? This one here is going to be a reduction, which K is going to be between 0 and 1, because this one is getting smaller. Whereas if now we want to look at the placement of, I'm going to look at A and A prime. So 1, 2, 3, 4, 5, 6. We have 6 on the X and 1, 2, 3 on the Y, and A prime is going to be 1, 2, 3, 4, and 1, 2. So in order to find our scale factor dilation, we're going to have to take new over old and set up our proportion. So remember, new X or Y over old X or Y, and then that will set up our proportion. So our new one is going to be, this is our new, and this is our old. So we're going to have to do 2 over 3, because we have our new over old, and 4 over 6. Again, we have new over old, new. So once we simplify this one, so this one is 2/3, whereas this one, if we simplify, this one also reduces to 2/3. So our K equals 2/3. All right. Moving to Tuesday, what is the volume of a cylinder with a base of 27 and a height of 3? So I'm going to go ahead and draw so again, we have our cylinder. We have here, so we have a height of 3 and a base area. So our area equals 27. So with this one, we have our formula area BH. Remember, this right here is the area of the base, which is pi r squared h. But in this case, they already gave us the area of the base. They told us that this is 27. And then we just have to substitute in our height. the number 2.375 times 10 to the 7th written in standard notation. So remember, this right here is scientific notation. So we are going to remember positive exponents equal larger numbers, and negative exponents equals smaller. So we have a positive exponent, so we're going to be creating a large number. So we're going to take our number here, and this 7 is the number of times you'll move the decimal, not number of zeros. Okay, so you're going to want to go ahead and count this out. 3. Make sure that you are filling in zeros as you go and moving it in the correct direction. In volume formula, what does B represent? Okay, I'm going to go ahead and skip this one because I have said it many times in this video so far. So the big B, remember, like you learned in 7th grade, when there's a capital, uppercase letters represent that a formula is inside. All right. An old wedding photograph, which is rectangular, has a diagonal length of 13.6 inches and a height of 12 inches. Find the width of the photograph. All right, I'm going to go ahead and draw my old photograph. So we have a rectangle which has a diagonal length, so in here my diagonal length of 13.6 inches and a height of 12 inches. And again with this one, I just want you to notice that we now have two congruent right triangles that we could solve for our solve for our third leg. So we have a 12, a 13.6, or if it's upside down, 13.6 and a 12. So just remembering which one, a squared plus b squared equals c squared. So remembering to formula, which is a squared plus b squared equals c squared. Substitute, remembering which sides of the triangle represent which letter. So remember that this one always points to our hypotenuse, which is the longest, which has to be C. All right, there's this page. Moving to Wednesday. All right, it says the square root of 10 is located between which letters on the number line. So what I would do is take this, the square root of 10, and turn it into a decimal. So remembering where the square root of 10 is, or you could think of perfect squares. So if we think of numbers that are close, the square root of 9 equals 3, and the square root, I'm trying to just find the square root of 16 equals 4, square root of 25 equals 5, and then seeing where this one is located between, and that could help as well. if point A square 3, 4 is rotated 180 degrees, what are the coordinates of A prime? What is the algebraic rule to describe a 180 degree rotation? All right, so on this one, there's some things you could do. You could plot this point on a graph, but since this one is 180 degrees, I've talked to my class a little bit about when somebody makes 180 degree life turnaround, everything changes, meaning that our x and y are both going to change. Both change signs. So I think you can, if you were to plot this point on a graph, we would have 1, 2, 3, 1, 2, 3, 4. So when you were to rotate this one 180 degrees, it's going to rotate 2 separate times. And moving to this one, which figure has a greater volume? So remember, we can solve volume equals big B H. Remember, this is going to represent the area of our base, which is pi r squared, because the area circle pi r squared, and these are both circles here for our base. So formula here, substitute. For our first one, we have a radius and a height of 3. So we're going to have pi times 3 squared, and then times 3. So when you solve that, you'll get your volume equals. So that's for this one right here. And our next one, for the second one, we have our formula is the same. Big BH, volume equals pi r squared h. So when we substitute, we have a volume pi times 2 squared times 6. And so when you substitute, or when you solve this one, you'll be able to tell which is bigger. All right, we're going to find the radius of our circle. All right, so this one is set up a little different, but remember, when we're looking for the side lengths of a right triangle, Pythagorean theorem. So we just have so remember that this whole thing is our diameter. So half would be our radius. So this is going to be like a 2-step problem. We're going to first have to solve for, this looks like we're solving for this right angle points to the hypotenuse with our formula of a squared plus b squared equals c squared. So they have, when we substitute, we have 6 squared plus 12 squared equals c squared. And once we solve this, we'll have 36 plus 144 equals c squared. 36 plus 144, we have 10, 8, 180. So we have c squared equals 180. And then remember, we're just looking for c. This is A, B, and C. So the square root of both sides, that will give us c. And then we're going to have to divide, since they're looking for the radius, we'll have to divide c by 2. All right, lastly, we have between what two integers does the square root of 181 lie? So we need to remember what an integer is. An integer is negative infinity to positive infinity, no decimals. So they're all numbers that, counting numbers on a number line, negative and positive. So when you turn this into a decimal, you'll be able to see between which two, between 3 and 4. I'm going to give an example. So the square root of 3 equals 9, and the square root of, that was backwards. The square root of 9 equals 3, and the square root of 16 equals 4. So any number between, any number between the square root of 16 and square root of 9 will be between these two. This is an integer, and this is an integer. All right. A pile of sand dumped on a driveway in the shape of a cone, 3 meters high and 5 meters in diameter. What is the volume of the sand? All right, so we have a new shape. Now we have a cone. So we have a diameter 5 meters and a height 3 meters. So we have our formula, volume equals 1/3 big B H. So I'm going to rewrite 1/3, and since we still have a circle as our base, so pi r squared equals our area. Pi r squared, and then H. So when we substitute, we're going to have volume equals 1/3 pi times, remember, again, this is our diameter, so we have to divide that by 2. So 5 divided by 2 is 2.5 squared times our height of 3. So when we solve, we're going to have something meters cubed. All right, on a coordinate system, triangle ABC is transformed to triangle A prime, B prime, C prime. This is done by lengthening the segments AB and AC to create segments A, B prime, and A, C prime. If segment BC is parallel to segment B prime, C prime, then which of the following statements are true? Okay. So that was a lot of words. So we're looking at, when we're talking about being transformed, there are the 4 types that we learned. And when you look at the answer choice, we have a dilation, we have a translation, we have, those are 2 types. And then there's the rotation and reflection. So remember, congruent means same size, same shape, everything. And similar is same size, same shape, different size. So, if this word here, they said lengthening, by lengthening segments. If it's lengthening, that means it is growing. So remembering that a translation, they're going to be congruent, whereas a dilation, there will be similar. What is the scale factor of the dilation that maps ABC to ABC? So let's look at which one is our. So this is our original. This is our pre-image and our image, pre-image and image. So this one is getting smaller, which is a reduction, meaning that our K, which is our scale factor, has to be between 0 and 1. So in order to find that, I'm going to find a point, A and A prime. So 1, 2, 3, 4, 5, 6, 7, 8, 9 on our X, and 1, 2, 3, 3 on our Y. A prime is 1, 2, 3, and 1. So remember, when we have to find, we're going to take new over old, and that will help us find, remembering that you have to put new X over old X and new Y over old Y. And then, so we have our X and our Y, X and our Y. So remembering that this is our new and this is our old. So set up that proportion and you'll be able to find what K is. All right, so hopefully that helps, and I hope you have a good week.